welcome back to another video. In this episode, we are going to talk about the reduction formula, to be precise, the integration. All right. Some integrals are too complex. They are very, very complex to integrate directly. So this comes in, what if we partition or we put them into similar powers, but very simple, okay, for us to integrate. So that is when the reduction formula comes in. All right, and the reduction formula, typical reduction formula looks like this, where the f of n and the g of n are the functions of n, right? And the I of n minus 1 is the integration reduction, right? So here, we're going to deal with the functions that are products or product functions today. Okay, so let's dive into it. We are beginning with the product function. So this function right here, xn e power x dx, we want to form the reduction formula to this particular function, right? So uv minus integral v du, right? So here, our u here is x power n, right? So u is equal to x power n, right? So when you differentiate both sides, you're going to have du is equal to n x power n minus 1 dx, right? Here we have the differential. Let's consider these two functions as our domain. So our domain here is going to be e power x dx. So integrating both sides, we have our v to be equal to integral of an exponential function is the same e power x, right? So now we have all the parameters. Let's substitute into the formula, right? But we know that I of n, in, which is this function, in is this function, that is this section, right, is equal to x power n e power x dx. That is the I of n. The in minus 1, so that our in minus 1 is equal to x power n minus 1 e power x, right? So from here, we come back to our formula where we have in is equal to uv minus integral v du, right? So we substitute these informations where our u is x power n and our v is e power x minus integral the v, which is e power x, and our du here is n x n power and then the x, right? So let's factor the n out. So when we do that, we have x power n e power x minus n integral x power n minus 1 e power x dx, right? So here, we know that our in minus 1 is this, right? So we do this substitution because we know that this whole thing is in minus 1. Of course, there is an integral here. So we have our in now to be equal to x n e power x minus n multiplied by in minus 1, right? So we have in is equal to x n e power x minus n in minus 1. And that becomes the reduction formula for this particular complex integrand. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.